Hello everyone, I would like to welcome you all to this course which is titled Applied Computational Fluid Dynamics, and as the name suggests this course is about applied aspects of the computational fluid dynamics. Many of you might be using computational fluid dynamics or CFD in short for various applications. In CFD, wherever there is a fluid, you can apply it, you can use it as a design tool, you can use it as a simulation tool, you can use it as a tool to basically control your designs or control the outcomes that you want. So, CFD is there everywhere, whether it is an automotive application, aerodynamic application, biomedical application, whether you want to research about clouds, about environment, about you want to make the weather predictions. So, wherever there is a fluid, you can basically apply CFD. Now, regarding the applied aspects, so if you are using CFD already, this course will be useful to you, because you will come to know why certain things work, why certain things do not work, right. So, it could be because of the boundary conditions, because of the models that you are using. There are many different kind of models in CFD. Okay. You might have heard about the turbulence models, but then you have LES, you have detached eddy simulation, and then finally, you have simulations without model, which is direct numerical simulation. The models have got their own limitations. For certain flows they may work, for certain flows they may not give you the results that you desire. For example, if the flow has got large separation, if it has got separation induced transition, okay, or if it has got relinearization, some of the models will not give you the correct result. Similarly, boundary conditions play a very important role in your computational fluid dynamics. If your governing equations are correct, your code is completely accurate and you have validated it, but you do not have correct boundary conditions, then you will not get correct values. So, this course, as the content suggests, it will teach you about all these practical aspects of using CFD as a design tool for your needs, for your applications. So, I will briefly go through the course contents. So, first we will review the basic fluid mechanics and thermodynamics. So, one important thing about this course is that it will primarily deal with the compressible computational fluid dynamics. So, flows which has got shocks, which has got the variations in Mach number, where the compressibility effect is important. So, you will learn about how to deal with those things in this course. We will look at different forms of the compressible Navier-Stokes equations, we will non-dimensionalize it, and we will discuss why the non-dimensionalization is important. Then we will go through some model equations. So, whether it is advection or convection, or whether it is diffusion, whether it is a combination of the two, what are the elliptic equations, hyperbolic equations, parabolic equations, how to identify them, and how do we use different kind of numerical schemes to basically target different kind of equations. So, we will learn about those schemes, we will learn about the explicit schemes and implicit schemes, we will solve these model equations. We will also look at the properties of different schemes. So, how consistent the equation is, how consistent the scheme is, can we expect stability from our simulation, can we expect convergence from our simulation. We will go into the different kind of schemes which has got upwind scheme, soft capturing schemes, compact scheme, and so on and so forth. We will devote 1 week in boundary conditions, discussing about different kind of boundary conditions that you see in your software or any tool that you are using, at inlet, at outlet, at far field, at valve boundary condition. You have periodic boundary condition, you have slip boundary condition, symmetry boundary conditions, all those things will be discussed in this course. We will briefly discuss about the finite volume method, because many of you use commercial codes like Fluent or OpenFOAM, which is based on finite volumes. We will touch on that. Then we will show you some examples of how to solve the Euler and Navier-Stokes equations, discuss some case studies. We will spend some time on Range equations and turbulence models, and finally, we will have some lectures on the LES, DNS, and other hybrid schemes. So, we hope that this course will be useful to you, and you will come to know how to use your code. If you already have a code, how to use it effectively, what to expect from your simulation and what not to expect from your simulation. Okay. Let us say that if you are not getting certain match from your Range model, you should know that this was expected. So, this kind of things will be known through this course. So, with that I welcome once again you all to this course. Thank you.